All right, so we left off with these two challenge problems. So I'm going to write this out just so I have some space to work. Tangent of theta minus 1 over tangent of theta plus 1 is equal to 1 minus cotangent of theta over 1 plus cotangent of theta. So thinking about this one, really neither side is necessarily easier or harder to work with. The left side we've got 2 terms divided by 2 terms, and the right side we've got 2 terms divided by 2 terms. So really it's just a matter of picking one side and sticking with it and seeing what substitutions or what things we can multiply by that will help us cancel things out. So when I look at this, I view that I have, if I'm going to choose the left side, so just for argument's sake, I'm going to work on the left, which means the right side is going to stay where it's at. I need to introduce cotangent somehow. Is really what needs to happen, right? I mean, I don't know how to get from tangent to cotangent. I could change these. I'm going to write this. Don't write this. You don't want to write this. I repeat, don't write this. Cotangent minus 1 over cotangent plus 1. But that doesn't really like get me closer to the tangent. Like, how am I going to make this thing switch into a 1 minus and this one switch into a 1 plus? Yeah, I don't really know. So instead, I'm just going to try to introduce cotangent. Sometimes it's a matter of just putting what you want into the problem. The only way I can do that, though, is to make a legal math substitution. So I'm going to multiply this whole thing by, oops, just moved my whole recorder, by cotangent of theta over cotangent of theta. Because if I do that, what I've really multiplied by is just 1, and that's an okay thing to multiply by. So now I'm going to actually multiply in. So I've got cotangent of times tangent of theta minus cotangent of theta over cotangent of theta times tangent of theta plus cotangent theta. And I'm still trying to get it to equal this red side. Well, this right here, cotangent of theta times tangent of theta, is really the same thing as cotangent of theta times 1 over cotangent of theta. And because they are reciprocals, this part in blue will just become 1, and then I still have that minus cotangent theta. This down here in red is another version of this right here, so those are still going to cancel. And I'm going to have 1 plus that cotangent of theta. And that is perfectly what I wanted to have on my right side. Okay, now the same thing could have been true if you had decided to start on the right. You could have introduced tangent over tangent and distributed in, and you would have gotten to the same one. Notice again, though, only one side at once. All right, last example. So this one we've got 2 terms on the left, 2 terms on the right. I need to somehow get cosecants and cotangents into cosecants and cotangents. Okay, well, I don't need to introduce anything because everything I want is already here. It's got to be just a matter of rearranging some things and using some identities. So hopefully you recognize that cosecant and cotangent are related with Pythagoras, but they're not related in the way we want them to be, because your Pythagorean identity doesn't give you the option of adding cosecant squared plus cotangent squared. So this side, I'm going to leave alone, this right side, and we're going to try to make sure we can prove to that. I'm going to start on this left side, and I'm going to factor this using a difference of squares. So this becomes cosecant squared of x plus cotangent squared of x times cosecant squared x minus cotangent squared x using our algebra skills. You can check that by multiplying back. Cosecant squared times cosecant squared gets us cosecant to the 4th. The middle terms, one's positive, one's negative, they'll cancel. And then the last terms, cotangent squared times negative cotangent squared is negative cotangent to the 4th. Well, now here's what I want to solve for, right? That's what's on my right side that I'm trying to prove, which means that I should be able to look at this one, and I have a Pythagorean identity that says 1 plus cotangent squared of x is equal to cosecant squared of x, which means that if I move that cotangent squared to the other side, this whole identity right here, part that's underlined in green, is really the same thing as 1. So what I have is this part in black times 1, which is my item in red. And that's it. It was just a matter of factoring using those algebra skills to get things to perfectly match. And again, when we write our answers, we're going to have perfect mathematical equivalent statements set equal to each other. All right, these take practice. Don't be scared of them. Don't always work backwards from an answer key. That's the worst thing you can do in this unit. Try them. Don't be afraid to mess up. Ask questions as you are trying your homework in class, and go to the MRC if you need some extra help. All right, you got this.